Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to use a geometric series to find the exact value of a repeating decimal, which is 0.075. And we have the bar at the top of 75, which essentially means that it's 0, 0, 75, 75, 75, and 75. So that 75 sort of like goes infinite many times. And again, we're going to use the geometric series, and we will put that first in the infinite series form, and we're going to use the formula for the convergence of geometric series. All right, let's get started. All right, so for this problem, we're going to write the repeating decimal in terms of geometric series. But first, let me just write what the repeating decimal means. So this essentially means that I'm going to put 0.075 and 75, so like repeats itself. Okay, so this goes on and on and on and on and on. Okay, so what I'm going to do next is to write this in terms of fractions. Okay, so for example, one by one, I'm going to write this. So 75, this 75 means like this is 75 over 1,000. This 75 is 75 over 5 zeros. Okay. And then the next 75 is 7 zeros, and on and on and on. Okay. So in the next step, since this goes on and on and on, I'm going to try to factor out this term, because this term is sort of like a common factor here. Okay, so pulling 75 over, in fact, 1,000 out, right? This is thousands. There we go. Okay, so the first term is going to be 1. And from one term to another, we just divide by 100. Okay, and the next term is going to be 10,000, and on and on and on. Okay. So now this has the form of a geometric series, right? Because here the 1 is just 1, the very first term. This term here is 10 squared. This term is 10 to the 4th. And I can even write this term as 1 over 10 to the 0. So now how do we sort of like grab the general term of the geometric series here? So this is equal to the sum, n starting from 0 all the way to infinity. Okay. 1 over 10. Well, we first have to put the a, which is 75 over 1,000, times 1 over 10 to the power of 2n. See, like here, the exponents are even numbers, so it should follow the pattern of 2n. So when n equals 0, here we go, we have 0. When n equals 1, this is 2. When n equals 2, it's 2 times 2, that should be 4. Okay? And we know when the geometric series converge, but before we jump into that, be careful, because I should probably write this term here as the power of n, right? So, well, the bottom is 1 over 100 to the power of n. So that's 1 over 100 to the power of n. Okay? So this is important, because geometric series is always following the form of a times r to the n, right? So here we go. So I'm going to erase this part. I'm going to replace this term by 1 over 100 to the power of n. Okay? So this will be 1 over 100 to the power of n. So now we have the perfect geometric series form, and the sum would be a divided by 1 minus 1 over r. So here this is a and this is r, right? And r is less than 1, so it's convergent, we know it. Okay? So this part is going to be what? 1 minus 1 over 100, so it's 100 over 100 minus 1 over 100, so it's 99 over 100. Okay, so this is 99 over 100. Okay, let me just move over. So then the sum is going to be 75 over 1,000 times, we flip the bottom over. So this is 100 over 99. Okay. So now this 100 cancels this 1,000. I have 10 in the bottom. Okay. So now let's try to divide this by 3 and this by 3. And we have more cancellations, right? Because this is divisible. 10 is divisible by 5. So divide this by 5 and divide this by 5. Okay, so at the top we have 5. In the bottom we have 2 times 33. So that is equal to 5 over 66. Okay, so going back to the original problem, I can represent this repeating decimal as the ratio of 2 integers, and that is in fact 5 over 66. If you use your calculator, if you divide 5 by 66, you're going to have exactly this form depending on how many decimal places you keep in the number. Okay. All right, in this table, I also looked at partial sums. Partial sums are like when you add only one term, it's 0.075. And then the next one, I have another 75 coming along, another 75 coming along. As you see, it's rapidly approaching 5 over 66 after the second term here. Right, so if you look at if you follow the reds are approaching 5 over 66, and again, this is a very rapid convergence to 5 over 66. All right, this is the end of the video. Thanks for watching.